Good morning, guys. So this is Arnab Chaudhary from VIT Bhopal University. Today is the second day of the YouTube channel. What we are going to do is we basically focus on solving the problem of the day questions given by GeekForGeeks. And today's question is basically the Fibonacci series up to the nth term. So a very interesting thing we have to note for this is what is a Fibonacci series. So we know that in computational algorithms and computational problems, Fibonacci has different type of approaches to which it can be solved. It can be solved using a while loop. It can be solved using a recursive approach. It can also be solved using, a dynamic programming logic. So what the three different type of logics are basically going to do is it is going to optimize the solution. So we can see expected time complexity of the problem is O(n) and space is O(n), and also see that you are given an integer n, return the Fibonacci series till the nth or the zeroed based indexing term. Since the terms can be become very large, return the terms modulo 10 to the power 9 plus 7. So a very interesting point to be noted over here is often when you're doing or computing Fibonacci numbers, the Fibonacci numbers go very high. So in order to reduce the time complexity of the machine and there will be a lag, we have to use an optimized solution. That is by we have to divide the module of 10 to the power 9 plus 7. So here is the class template for the Java file. Class solution in series. So what we are going to do is we have to take the modulo value first and store it as int modulo 10 to the power 9. So 10 to the power of 9 plus 7. 10 to the power 9 plus 7. Yeah. First, we have to take an initial value of that Fibonacci series. So let's take since this is the series is given in the array format, we have to take an array. So int Fibo equals to new int n plus 1. So next comes is the first and the second element. We can predefine the first and the second element of the Fibonacci series. So we can write as Fibo of 0 is equals to 0 and Fibo of 1 is equals to 1. And now we have to put the loop. So the loop starts from the obviously from the 0 of 1 to third element, which is second for the series. So I equals to 2 semicolon I equals to 2 I plus plus. So we are making the loop. So for reference, I can put zeroth or first starting the loop from second element. So in this loop, what we are basically do is we have to put the Fibo of I equals to Fibo of I minus 1 plus Fibo of I minus 2. And since we have to return the modular value, we have to divide it with modulus function. We have to do the modulo operation, and then we have to return the Fibo. So this is all about the problem. Let's try to see how it is solved. Let's try to compile this. So you can see there's a little bit of compilation error maybe. Let me check the error. I've done. Uh, what I've done is in series IDN and modulus of 10 to the power 9 plus 7. Okay, 10 to the power 9 plus 7 and Fibo equals to new int n of plus 1. Okay, and Fibo 0 is 0, Fibo 1 is 1, I equals 2, I less than equals to 0. I've made a very foolish mistake. Yeah, now it should work. Um, since Fibonacci numbers can become really large, therefore sometimes the computation time also becomes long. What's the problem? Yeah. So let's submit our problem. Today's problem of the day is Fibonacci number to the nth series. Okay, the 4 test cases have passed, but some output differences after the 8th turn. So what is it? Let's we ask the yogi. Yo, we are AI bot. Make sure using correct syntax. Okay. For syntax, we cannot write modulo 10 to the 9 like this. So we have to maybe put some zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7. So yeah, 8 zeros. Let's try. We have to put the zeros correctly. 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 2, 3, 4, 5, 6, 7. 1 0 is missing. Now let's try to compute again. So yeah, the test cases are running very quickly, and I hope that it works. Yeah. So we have completed 38 days in my Geek for Geeks account, but I am looking forward to post every single day, becoming consistent enough to show you guys that coding is not that hard, and it's just about a little bit of discipline which you need to put in. And there will be failures, like you saw, like simple problem of Fibonacci when there were like 3 to 4 chances